All right, this is how to calculate the confidence interval of an estimated population proportion. So let's start with the same data set we've been looking at, the trees. We know we're going to use n later, so let's say the n row of trees. We've got 31 observations. We have for each observation the diameter of each tree, the height, and the volume. So this is in inches, the diameter in inches. So let's say that the same logging company that we've been talking about wants to go in and cut down those trees, but because of an EPA regulation, we can not cut down a tree that is greater than 18 inches in diameter. So we need to figure out what is the proportion of our trees based on our sample. What is the proportion of in our grove of 100 trees? How many of them will have diameters greater than 18 inches? So we can plot that just to start. We can take a look at the density of girth. And so 18 comes in right here. So all of these trees we can cut down, but anything above 18 we cannot. So here's what we need to do. First, we need to figure out what is our population proportion. And to do that, we need to say, is girth greater than or equal to 18? Now, if we hit that right now, it's going to return false every time that it is less than 18 and true every time it is greater than or equal to 18. And if I sum that up, if you remember, true is 1 and false is 0. So I can sum this up, and 3 out of my 31 trees have a girth or a diameter greater than 18 inches. And if I divide this by my sample size, and here is my estimated population proportion, just about 10%, just under 10% of the trees are that size. So we can multiply the 10% times the 100. We can see we got 10 trees that are that size, but they want us to be, they're being really strict this time, they want us to be 99% confident that we have the possible range of the probability, or the range of the proportion of trees that have girth greater than 18 inches. So the equation for calculating that is here. Here's the z-score, which we're going to calculate the same way we did before. We're going to multiply that by the square root of our sample proportion times 1 minus our sample proportion, all of that divided by n. Okay, so it's pretty simple. So our z is going to be, again, the qt function, 1 plus our confidence level, divided by 2, and our degrees of freedom are always our sample size minus 1. So our sample size here, or our z-score is 2.7. So our confidence interval indicates that we need to be within 2.7 standard deviations of our mean, and if we're inside that, then that's the confidence level we're looking for. So our QI, or our CI, our confidence interval, is going to be equal to z times the square root of p times 1 minus p divided by n. Alright, is that the equation we've got there? Z times the square root of p times 1 minus p does that look right? Z times the square root. That's right, isn't it? We'll just call that P. So our CI, our CI, what do I keep saying CI? Our confidence interval is 14.6%, or about 15%. So this is a very wide confidence interval. So what we're saying here is that we are 90% confident that the number of trees in our sample, or the number of trees in our population that have diameters greater than 18 inches is essentially zero, because we really can't have a negative 4% here, but it's less than 24% of the trees. Right? If we change our confidence interval to 90, then we're less confident, which means we can have a smaller confidence interval. So now we're 90% that it's between just barely or just over 0.5%, but less than 18%. So most of our trees are much smaller than 18 inches around. But that's how you calculate the confidence interval of an estimated population proportion.